Well, hello everyone. This is David Holzhauser, your extension soybean agronomist. We're with Virginia Tech and for Virginia. Unfortunately, I won't be able to be with you this year at the Eastern Shore Ag Conference since this is a virtual conference, but maybe this is the second best thing that we can do this year. Today, I would like to talk about three things that I've been doing quite a bit of research on in the last few years. This is planting date, maturity group, and seeding rate. I'm not going to share a lot of results with you today. I'm not going to share a lot of data with you today, but I'll try to summarize this. We're going to try to get through this in about 10 minutes. But let me first of all say, if you've got questions or comments on this, please let me know. And then we'll be getting, once we fully analyze all these data, we'll have a better idea of the best planting date, maturity group, and seeding rate. Right. And we must realize that these three things interact. They not only interact with each other, but they interact with the environment that soybean are growing on and the location and time of year. So as we move through this, just be sure to keep that in mind. Now, when we're talking about these things, the three principles that I've espoused over and over through the years, position the soybean for most efficient water, light, and nutrient use, and least temperature stress, then grow more leaves and reproductive nodes, then protect and maintain that leaf area. Those are the principles that really apply to almost anything. So I'm going to keep that, and I'll show you how if we keep these. I'm going to focus mainly on the positioning part of this presentation, but we will, maybe in another time, we'll get to more of the grow and protecting. Okay, position, soybean yield and planting date. Now, this is a graph that I've shown over and over and over again throughout the years. Basically, we get very little yield loss up to a certain planting date, and then yield just falls rapidly. This is largely our double crop soybean production. Now, if we can maintain a leaf area, high leaf area, 3.5 to 4 layers of leaves per acre of ground, or per layer of ground, and get that established by the early pod production stage, we can generally maintain our yield. But with double crop, we just don't have the time for that. But let's look a little closer at this, at the full season part of this curve. Now, let's say we're going from June 15th planting date to May 15th and to April 15th. And generally, we gain about 10 days for every 30 days earlier that we plant. So, gaining maturity theoretically gives you a slight yield increase, but I haven't always seen that. Now, if we integrate maturity group in with that, you can do the same thing going from a group 5 to a 4x3. Every time you make that shift, you're gaining another 10 days of maturity. So, theoretically putting these together, going from say a late 4 to a late 3 variety, and then also going from a May planting date until a April planting date, you can theoretically gain 20 days in maturity. The idea of this is if we push that those soybean reproductive stages early in the year, you've got more sunlight, but that is only the case if you don't have any water or heat stress, or if you got consistently high yields on that tract of ground. I've seen it work, but this is nothing that I am promoting going to this early soybean production system. Now, and that's solely because you push these critical days of especially early seed, field, and pod production too early in the year. We're going to push that into drier and hotter times of the year, and we don't necessarily want that. My data basically show this curve, this is flat. So the idea I just spoke about really holds less merit in Virginia than it may in some other areas where they generally have better soils and cooler growing conditions, more rainfall or irrigation. How does maturity interact with this? Incorrect maturity, the first thing you do, and this is usually when you go to an earlier maturity group, whether you're moving from a 5 to a 4 or a 4 to a 3, you're going to have to plant these earlier when you go to an earlier maturity group, because this falls very rapidly early on, earlier than it would normally if you use that correct maturity. I have even seen the case where if we go too early of a maturity group and too early of a planting date, we end up lowering the yield there. And that's solely because we're pushing that critical stages to a hotter and drier time of the year. Now, this is under irrigation. You can avoid the water stress, but you can't always avoid the heat stress. So good land, soil, high rainfall, and correct maturity, you can keep this this yield up pretty well, even into the relatively late planting dates. Now, incorrect maturity and poor land. I showed you what would happen with incorrect maturity. If you got poor land and incorrect maturity, the yield will drop off even more. And that's solely because under dry land situations, we are increasing the risk of moving those critical stages to hotter and drier times of the year. General rule of thumb is later, if you got a late planting date, go with the later maturing variety, and a less productive soil, go with the later maturing variety. Because then what we do is we push that beyond those hot and dry times of the year. Just to let you know, we've completed 3 years of research of planting date and relative maturities, going from mid-3s all the way to mid-6s, 3 different planting dates. So I'm not going to go into any of that data today. We're summarizing it and try to have a better complete picture for you in the future. But basically what I showed you is what I've found in that case. All right, so we're looking at this. Let's talk a little, incorrect maturity. If you take that out, then generally just poor land and rainfall means this is going to drop off earlier. And of course, planting date becomes more critical. Later maturing varieties and somewhat later planting dates before mid-June, not real late, can help solve poor soil problems. So keep that in mind. Now let's look at seeding rate. Seeding rate's too low. It's going to interact with planting date and of course maturity group too, but let's just think about planting date now. Seeding rate's too low. We're really going to get that more rapid decrease and even a greater decrease in yield. Now, on the other hand, what I have found that occasionally we have been able to correct low yields with higher seeding rates as the planting date gets later. The problem with when you get too high a seeding rate becomes the seed cost. So yield-wise, we can maintain the yield with higher seeding rates, but it's not always cost-effective. Long story short, regardless if we're looking at seeding rate, planting date, or maturity, by the time this is full flower to early pod development, I want things to look like this, not like this. These were pictures were all taken at early pod fill. Okay. Current seeding rate recommendations, 90 to 120,000 seed per acre full season. I've got a bigger range with double crop. That's because planting date is so important there with seeding rate. And maturity group too. You go to an earlier maturity group, the higher the seeding rate you're going to need. Same thing down here. I want you to look at this picture. This was taken this year from early May. We were trying to get a mid-April. That didn't work out, but an early May planting date on a really good soil. We had good rainfall in that location this year. We've got 7 plants right here in about 2.5 feet, 2.5 to 3 feet. Let's just say 3 feet. And that's maybe a little high for full season, but that's generally would be a good recommendation over 3 feet. But notice this one single plant at this very low seeding rate, it yielded less than this, but not that much more. That's soybeans competitive, it's compensatory ability. Keep that in mind. We finished 4 years of seeding research this year. I'm not going to show the data for lack of time, but these are the locations we had. These are small plot studies. We also went on farm studies over the last few years, and there we're doing yield maps. as well as we're taking some growth readings through there. So that about wraps it up for me. I appreciate your time. I want to thank, and let me share my screen one more time because I definitely want to thank these people. I have time to see this. These are all the farmers I've worked with this year, as well as the technicians that I've had a privilege to work with that are working in my team. So, and also thank you, all the farmers, because your checkoff dollars provided the funds for this research. So, greatly appreciate your time today, and look forward to maybe possibly next year we can do this in person. So